This is example 6.6 from Discovering Design with Chemistry. The first part says, what is the formation reaction for aluminum bromide? Well, aluminum is here and bromine is here. So we're mixing a metal with a non-metal. And so we're going to have an ionic compound. So aluminum is in column 3A, so it has a +3 charge. Bromine is in 7, so it has a 1- charge. So when we mix them, we get aluminum with a 1 and bromine with a 3. So that's what we are creating in our reaction. When we put these two together, the aluminum is just one atom and the bromine is a mononuclear diatomic atom, and so it has to have a 2 there. So let's look at these two for a second. The aluminum, there's 1 on each side, so that's balanced. But the bromine has 2 atoms on one side and 3 atoms on the other. And we know if we multiply the 2 by anything, it's not going to make a 3, and the 3 by anything is not going to make a 2. But we know that we could multiply them both by the opposite, by each other, and create 6. And so let's do that. Let's put a 2 here and a 3 here. And that means we now have, I can make my chart down here, aluminum and bromine. On the reactant side, I have 3 times 2 makes 6 bromine. And then on the product side, I have 2 times 3, and that makes 6 on this side. For the aluminum, I have 2 on the product side, but on the reactant side, I only have 1. But if I put a 2 in front of it, it won't affect anything else. But it gives me 2 atoms of aluminum on that side. And so now it's balanced. And we can go back and check one more time if we want. All right, let's look at the other part of example 6.6. So the other part of the example says, what is the decomposition reaction for calcium carbonate? And they give us the formula for what that is. So that means we're going to start with calcium carbonate and we're going to break it into its pieces. For right now, we haven't started talking about carbonate and things like that. So we're just going to break it into all 3 pieces. Oxygen, again, is one of those homonuclear diatomic ones, so we have to have O2. So let's look at our numbers here. Calcium has a 1 on each side. Carbon has a 1 on each side. Oxygen has a 3 on the reactant side and a 2 on the product side. So it's just like the other one. We could again do the same thing that we did last time where we add a where we multiply them by the opposite. We can also do the fraction thing that we did in example 6.5 where we multiply this one by 3 over 2 because 3 over 2 times 2 is just 3 and that fixes it. And then we take the entire equation and we just multiply it all by 2 to get rid of the fraction. But you can do it whichever way you want. Because I just showed the other one, I'm going to stick with the fraction version for this one. So this will fix the oxygen, the calcium, and the carbon were already right. And so the only thing I have to do now is fix all of the numbers. And so let's double all of them. So we're going to put a 2 in front of this, and a 2 in front of this, and a 2 in front of this. And then the last one has 3 over 2, and when we double that, it just becomes a 3. So let's check to make sure we're balanced here. We have calcium, we have 2 on the reactant side, and then 2 on the product side. Carbon, we have 2 on the reactant side, and then 2 on the carbon side. And then for oxygen, we have 2 times 3 is 6 on the reactant side, and 3 times 2 is 6 on the product side. So this is our balanced equation. If we had wanted to do it the other way, where we multiplied them both by the opposite, we would have put a 2 here from the start to go with this 3, and a 3 here from the start to go with this 2. And then when we checked our other atoms that we're working with, we would have seen that this 2 right here doubled the amount of calcium and carbon, which would have led us to add a 2 here and here. So it would have still had the same end result and kind of the same process, but a different perspective of thinking. Whichever method works for you is great, or you can choose based on each problem which method you want, whether you want to put a weird fraction in there and then fix the whole thing by getting rid of the fraction and multiplying everything by the same number, or you can play with the numbers in a different way.